just a small remark that I forgot to mention in the previous video. I just want to clarify exactly why this matrix vector multiplication with this target concentration here on the right exactly gives us the solution that we're looking for. Just maybe make it a bit more intuitive. So let's look here at the first row only. So the first row of this matrix, which is the mass fraction matrix, composed out of mass fraction vectors, which are the columns, stands for, the first row only, stands for nitrogen. So it's the nitrogen fraction of each of the salts. And remember, in order to get this, the first element in the resulting vector, we multiply the first row by the entire column vector here. And we do that element by element. So we multiply this 139 ppm by potassium nitrate. What is potassium nitrate? The amount of potassium nitrate that we would like to have in the solution. Now, imagine here that instead of everything here being unknown, we have quantities here. So instead of KNO3, we have an actual number. 2 grams, 5 grams, 1.7 grams. So what is this product of the first row and the column matrix, you can call it now the salt, not column matrix, or column vector or salt vector, tells us exactly. It says that we have 139 ppms times the amount of potassium nitrate we have, right? So this is exactly how much nitrogen we get from potassium nitrate. Then 0 times the amount of monopotassium phosphate. Then 0 again times the amount of potassium sulfate, because these two salts don't affect the amount of nitrogen. Then 119 ppm per the amount of calcium nitrate, tetrahydrate, etc., and 0 for the rest, etc., etc. And exactly when we add up all these products, we get 150 ppm. We get 130 ppm per gram times the amount of mass of potassium nitrate in grams, plus 0 times these salts, plus 119 times the amount in grams we have from this salt. So it exactly calculates for nitrogen how much each of these compounds adds to the solution. And if you look, for example, at calcium, it's the same story. The first 3 salts do not add any calcium to the solution, but when we multiply the fourth column, the first element that isn't 0 is 170. It's 170 ppm that comes indeed from calcium nitrate tetrahydrate. So that's the 170 here is the mass fraction in ppm per gram of calcium inside calcium nitrate tetrahydrate. So to that we add 715, which is the mass fraction of calcium in calcium oxide, by multiplying this in the amount of calcium oxide. And to that we add the mass fraction value of calcium from calcium chloride, bihydrate here, and of course 0 for magnesium sulfate. And when we add all these together, we get 200, which is all the different contributions from the different salts. So I hope this point is a bit more clear. I hope it makes it a bit more intuitive.